Hello everyone, thank you for attending. Welcome to our live stream event about how our ArcGIS Location Platform can give you superpowers when you want to include location intelligence in your apps, projects, and integrations. What we will present today is intended for developers who are building applications and looking to integrate location services that are offered by Esri. Joining us today are Esri's developer advocates who can't wait to show you the power of our services. I'm John Foster. I help manage the developer experience team. And joining me today is Alan Wafron-Braz, principal product engineer and leader for our product engineering team, and Raul Jimenez Arteaga, a developer advocate and leader of our developer outreach team. Esri's ArcGIS system offers various products and services that specialize in specific use cases for different types of business requirements. This is why we offer many different products. There's ArcGIS Online. This is a software as a service Esri managed in the cloud as a complete GIS system of record. ArcGIS Enterprise. This is on-premise, self-hosted, complete GIS system of record. And ArcGIS Location Platform, a platform as a service, Esri managed cloud services designed for developers. Now, all of these Esri products support content management, geospatial services, developer tools, and so much more. Today, we are going to focus on how ArcGIS Location Platform is optimized for developers who want a fast and cost-effective way to integrate location intelligence into their apps. Today's live stream is going to focus on the three most requested capabilities, and that would be maps, search, and routing. We will present the key technical capabilities of these services and explore how you can leverage these capabilities to solve the problems you need to solve. The platform is highly secure, and it operates on infrastructure that is designed to handle millions of concurrent requests globally. Esri takes security and privacy very seriously. Your data is yours. You are in complete control over any data that you store on the platform, and Esri does not record telemetry on your users or on your data. All maps and data are hosted in Esri secure infrastructure with compliance standards such as FedRAMP, ISO, and HIPAA. And there is so much more for you to explore. We don't possibly have time to cover everything today, but we'll share some links at the end of this live stream, and you can check out the links and see if anything else is something you would like to integrate into your apps. Our maps and services are compatible with a wide range of SDKs from Esri and from open source providers. For web developers, there's the Maps SDK for JavaScript, there's ArcGIS REST.js, an open source JavaScript wrapper library around our location services, and there's open source libraries for Leaflet, MapLibre, OpenLayers, and Cesium. And you'll see some of this demonstrated later in our demos. For mobile app developers, there's the Maps SDK for Swift, for Kotlin, and there's a cross-platform SDK for Flutter. For systems integrators, there's the Python API, there's .NET APIs, there's integrations with Node.js, and you could always rely on the REST APIs to cover all of our services. The advantage of using ArcGIS Maps SDKs is that they are under constant development by Esri's engineering team, and they always contain the latest features and are the best way to consume ArcGIS services. Esri also invests heavily in open source mapping libraries. What this all means is that Esri meets you where you are, providing high-quality SDKs for almost every development platform that developers are using today, and we're constantly responding to the needs of the developer community. And speaking of developer community, ArcGIS offers a very robust developer community. There's the ArcGIS blog that has lots of developer-focused articles, and there's a quarterly newsletter intended just for developers. There's Esri Community with very active forums that are around all of the Esri developer products and managed by Esri development teams. And there's social media presence, and most importantly, there are YouTube videos that are focused on developer topics. And there's a very active developer community on GitHub with 650 open source projects. ArcGIS is a leading geospatial technology available today. It is used by thousands of businesses around the world and every industry. It's the secret sauce that powers many business decisions. These are just a few of the success stories of those who are using ArcGIS services today, and these are the same services that we are demonstrating. At the heart of ArcGIS are powerful maps designed to help you create engaging interactive mapping applications. These services deliver the foundation for rich dynamic maps across web, mobile, and desktop, perfect for developers, designers, and organizations who are looking to build a powerful and unique mapping experience. You can jumpstart your projects with over 50 pre-built map styles authored by Esri's cartographic team. Each style is crafted for clarity and performance, ensuring that your maps look professional right from the start. Esri maps incorporate a wide variety of authoritative content from government agencies and Esri's community of contributors. Now I'd like to hand it off to Al, who's going to demonstrate maps in action. So over to you, Al.
Okay, thanks, John. Let's get started by looking at the Basemap styles you get with ArcGIS Location Platform. You can access the styles with two location services: the Basemap Style Service, which provides vector tiles, the Static Basemap Tile Service, which provides raster tiles. The styles are grouped into two families. ArcGIS Basemap styles include data from Esri, authoritative data partners, and government and community contributors all around the world. Open Basemap styles include data from Esri, the Overture Foundation, and OpenStreetMap. Both style families include professionally designed cartographic styles, 2D features for land, water, boundaries, roads, and labels, 3D features for buildings, landmarks, and terrain, light and dark modes, and high-resolution satellite imagery for the entire world. Both services run on Esri's fast and secure global infrastructure. Regardless of the type of application you're building, Basemap services provide the styles and formats you need to deliver high-quality mapping experiences. To learn more, be sure to check out the Mapping and Location Services Developer Guide. Location Platform supports building browser-based web and mobile mapping applications with the ArcGIS Maps SDK for JavaScript. The SDK is a complete toolkit designed to work seamlessly with location services. It provides modern web components for displaying interactive 2D, 3D maps and scenes. It also supports advanced features such as data-driven visualization, editing, search, routing, and 3D analysis. All components are built with a calcite design system, ensuring a consistent UI and strong accessibility support. Here's the exact code used to build a simple 2D, 3D mapping application with web components. It contains a 3D scene component, which accesses and uses the Basemap style service, a search component, which uses the geocoding service, 2D map as an inset map, and a Basemap gallery component for selecting styles. This application uses simple HTML to wire everything up. No JavaScript was required. As a developer, you can use the SDK to quickly build professional 2D and 3D web mapping applications with just a few lines of code. To learn more about the SDK, explore over 400 samples in the developer documentation. Location Platform also supports building web mapping applications with open source libraries. You can develop with Leaflet, MapLibra, OpenLayers, or Cesium.js. You can also use officially supported ArcGIS open source libraries and plugins that make it easier to work with location services. This is a simple mapping application built with the MapLibra ArcGIS plugin, ArcGIS REST.js open source library. Both are maintained by Esri in the community. With just a few lines of code, you can use the plugin to access a Basemap style, set the style preferences such as places, label language, and boundaries, select a new style using a custom widget to access the Basemap style service, or find places using another custom widget which accesses the geocoding service. This app was built using vanilla HTML, CSS, and JavaScript. Open source libraries and plugins let you integrate with ArcGIS Location Services using the UI framework and the tech stack you prefer. To learn more, be sure to check out the open source developer guides. Location Platform also supports mobile and native development with ArcGIS Maps SDKs for Swift, Kotlin, Qt, .NET, and Flutter. These SDKs let you build high-performance 2D, 3D applications that work seamlessly with location services. This application uses ArcGIS Maps SDK for Flutter to build an online-offline mapping application. The SDK provides an open-source toolkit with several UI components for developers. This app uses the toolkit's Basemap component to select different Basemap styles. The styles are easy to use with the style enumerations, and you can build with them directly using the API. After choosing a style and an area of interest, you can download a map package for offline use. You can generate map packages on demand, like this application is, or you can pre-create them beforehand using ArcGIS developer tools. ArcGIS Maps native SDKs lets you build simple or advanced mobile mapping applications. They also let you use native development languages and the frameworks you prefer. To learn more, go to the Offline Mapping Apps Developer Guide. If you can't find the Basemap style that works for you, you can create your own with the ArcGIS developer tools. The ArcGIS Vector Tile Style Editor gives you full control over your Basemap design. You can use it to customize colors, fonts, icons, and labels to match your brand or personal styling preferences. This example shows how to create a custom Basemap style based on the Esri logo brand colors. You can use the editor to select and make changes to many layers, such as roads, boundaries, and water bodies, all at the same time. Change the fonts and colors for your place labels, or individually select a layer to make more specific customizations. Once finished, the custom style is securely stored in ArcGIS. It can then be accessed by all of your custom web and mobile mapping applications. The Vector Tile Style Editor is a key productivity tool for developers who want to create their own custom basemaps with no coding required. ArcGIS Location Platform also offers flexible business models for consuming Basemap services. In this example, the left side uses the tile-based model. It shows how tiles are consumed as a user interacts with the map. The right side uses the session-based model. It shows how a single session can be used for up to 12 hours, no matter how many interactions occur and tiles are consumed. Both models are simple to implement, and you can switch between them by changing the access token type. These flexible consumption models make it easier to predict and manage Basemap costs for both small and large-scale projects. Now let's take a look at some real-world applications built with ArcGIS. Fulcrum, a field operations platform, migrated its mapping capabilities to ArcGIS Location Platform to improve performance and reduce costs. They started by replacing third-party maps with ArcGIS Basemap services. Over time, they expanded to include ArcGIS Maps SDKs, geocoding, and data services, supporting both online and offline workflows for field workers and real-time dashboards for managers. This shows how developers can start small and scale up using ArcGIS Location Platform tools, APIs, and location services all together. Here's another example that Red Bull designed. They wanted to create an immersive 3D experience for the X-Alps competition. The application supported real-time GPS tracking and updates for all athletes, 3D visualization of terrain using high-resolution satellite imagery, multiple location services including the elevation service, and strong enterprise reliability powered by Esri's global infrastructure. With ArcGIS Location Platform, SDKs, and services, Red Bull delivered a fast, high-quality mapping experience for thousands of viewers watching the competition. That's it for Maps and Basemap services, John. Back to you.
Thanks, Al. Those demos were great. Can't really wait to see what you guys all come up with using these demos as a starting point. But these are the key takeaways from Maps. There's multiple data formats that cover a variety of different use cases and performance requirements. There's authoritative data that is updated frequently, and it's all delivered on a performant global infrastructure with flexible pricing. So to learn more about Maps and how to build mapping applications, check out our tutorials and samples that are available on the developer website. The next set of services we want to bring to your attention is Search. Search brings world-class location intelligence to your applications. With high-quality geocoding, place details, demographic data, it delivers fast, accurate search for addresses, places, points of interest anywhere in the world. Decades of Esri experience with frequent updates and flexible APIs are going to give you a unique advantage when building reliable global location experiences. With our search capabilities, you can quickly explore neighborhoods, discover POIs, access contextual information around locations. You can also work at scale with bulk geocoding, enabling you to store geocodes long-term, and you can integrate results into your enterprise and IT workflows. And for deeper insights, the Places and GeoEnrichment services let you add business information and demographic data for any location or custom data set. This API can return statistically correct demographic data for the exact geometry you request, such as a point buffer, a polygon, or a drive time isochrone, and it covers more than 1,500 demographic variables. Search services can be used in many different scenarios. You can enrich records with permanent geocodes for analytics, risk assessment, logistics optimization, building dashboards, and many other use cases. You could speed up address entry and boost conversions with real-time address suggestions. You can reduce errors and failed deliveries through address validation and address normalization. You can clean and standardize messy address data with deduplication. You can power asset locators and store finders for service areas, delivery tools with precise location data. You can create nearby experiences by searching within a radius or around a user's position. You can find high-precision points, such as building entrances or sub-addresses, for example, within an apartment complex, malls, office parks, and similar locations. And you can turn GPS or sensor data into meaningful place data by reverse geocoding coordinates into addresses. Now, Esri has been evolving and enhancing this global data coverage for decades by working with authoritative data sources, including commercial data providers, government agencies, postal authorities, statistical and demographic agencies, and including contributions from the user community as well. All of this is providing high-quality, accurate address data. So your power is in the quality of this data, and this has been validated by many developers. Now, to see the many use cases for search, we're going to hand it off to Raul, who's going to demo search services. Raul, off to you.
Thank you, John. Let's start with forward geocoding. It helps you handle messy inputs. So this app shows how the service understands multiple types of addresses, from straightforward street addresses to places of interest such as name of malls, landmarks, restaurants, etc. But also search for street intersections, like in this case, and even disconnected street intersections. And not just that, you can also search for distant markers like mileposts among many other types of locations. So as you can see, this service understands more location types than typical geocoders. Now, let's take a closer look at how it works. To get started, you just need to type the address and introduce an API key. By default, the geocoder will return the rooftop location for that address. Now, you can refine results using additional parameters. For example, you can use the location type =street to get a navigation-ready point very useful for deliveries, routing, and fields operations. Using the outfields parameter, you specify the attributes you want to get back, and you can request up to 71 attributes that you can use to clean, normalize, or enrich your data. In this demo, we are selecting 14. You can also reduce noise by filtering candidates. Use category selection across more than 350 types, and only get back relevant candidates to avoid paying for low-quality matches. And if you want to store results in your database, you simply set the for storage parameter to true. And keep in mind that in this demo, I only used 6 parameters, but the service supports more than 30 to fine-tune your results. In summary, forward geocoding gives you reliable results and clean structured data with the control and accuracy we are known for. To try it yourself, you can make direct REST API calls, use our public Postman workspace, or get started quickly with any of our Python or JavaScript libraries. Okay, now let's move on to another common use case for the geocoding service, which is address autocompletion. This one helps improve applications that require fast, error-free form entry like online checkouts or incident reporting. Because as we all know, typing addresses is really slow and error-prone. With Autosuggest, your users will get address candidates as they type. On this other demo, you can see an integration with ServiceNow through a custom widget. And you know what? You can use the suggest operation at no additional cost. So, if you need to enhance the user experience of introducing addresses, I highly encourage you to try the suggest operation. Next up is reverse geocoding. It converts coordinates into human-readable structured addresses. Here, you are seeing a real-time tracking app that is showing GPS coordinates from a vehicle tracking device along with the closest address returned by the reverse geocoder. You can do this using the REST API or any of our libraries, like the ArcGIS REST.js in this case. And the API returns normalized address details you can store, display, or fit into your workflow. And the same geocoding service also processes large batches of addresses very efficiently. So if you deal with large datasets, this solves the problem of turning millions of messy addresses into clean, usable locations very quickly. To give you a sense of scale, you can geocode tens of thousands of records in minutes. But if you want, you can upload files up to 2 GB with millions of addresses. It is as simple as uploading a CSV, waiting a few minutes, and you will get a results file back with both matched and unmatched addresses. Moving on, ArcGIS also supports finding points of interest across more than 1,200 categories. This app shows how you can search across several of them within the map view and get rich place details like phone number, website, and social profiles. For example, you can filter by categories such as parks. And you can optimize your queries using a location and a radius. Here, we are searching within a mile. And now, we are looking for hotels within half a mile near Fulton Center Station. And finally, searching for restaurants within 250 feet. So we invite you to try this service if you are looking for rich place details for your apps. And last but not least, you can also search more than 1,500 data variables like demographics, socioeconomic indicators, consumer spending, and many more using the Analysis Variable Finder. This includes not just current data, but also historical and forecasted data as well. All of this is powered by the GeoEnrichment service. This example shows that in action. The key is that you can send any area, like a block group, and we will handle all the boundary complexity behind the scenes to return statistically correct information. In this second query, I'm using a 10-minute drive time polygon, also known as an isochron, to query the service. I personally think this is really cool. You can get statistically correct information for the area defined by this exact polygon. This is why many organizations use the GeoEnrichment service to enhance records in their business systems. Here is an example of an integration with Salesforce to enrich a customer record with location-based insights. In short, GeoEnrichment provides accurate demographic and market insights for any area you define. Back to you, John.
Thanks, Raul. Those are some great-looking demos. So here's a summary of what we covered with search. There's a robust API with multiple options and support for interactivity and support for large volume processing. And all of this built on top of authoritative data. If you'd like to know more about building mapping applications with the geocoding, places, or GeoEnrichment services, be sure to check out the Mapping and Location Services Developer Guide on the Esri Developer website. Now let's move on to routing. Routing isn't just about finding a path. It's about delivering efficiency, precision, and adaptability. The routing service offers global, high-quality coverage from everything from simple point-to-point navigation to complex fleet optimization. The routing service offers many different algorithms for common and highly specialized use cases. You can build advanced trip planning and navigation apps for personal enterprise use, optimize route planning with constraints like the travel mode, multiple stops, incidents, barriers, and many other options. Optimize multi-vehicle deliveries with constraints like road restrictions, delivery windows, and different vehicle types. You can leverage live traffic and predictive analytics for real-time decision-making. You can generate service areas and reachable zones based on time, distance, or travel mode, like walking, cars, and trucks. So for example, a utility company defining coverage zones for emergency repair crews out in the field. Support multimodal routing for diverse transportation networks, and you could snap GPS coordinates to the underlying road network to provide a more reliable representation of the actual route that was taken. So whether you're managing package delivery, fleet management, emergency response teams, field workforce, or you're just getting your user from point A to point B, routing empowers you to employ sophisticated routing algorithms, help manage your costs, improve customer satisfaction, and streamline your operations. And the routing service offers global coverage, with some areas of the world having more robust coverage than others. And then, like I just mentioned earlier, there are supporting services like the traffic service with 5-minute traffic updates and the Esri Community maps of contributors of road closures and other supporting resources. So having said all of that, let's see some demos. We're going to hand off to Al now to demonstrate the routing services. Al, offer to you.
Okay, thanks, John. The ArcGIS routing service can find the best route for visiting one or more destinations on a trip. To do so, you can use the solve operation. The operation works seamlessly with the live traffic service. All traffic data is updated every 5 minutes. In this example, we want to find the best route from the Denver airport to a number of ski resorts in the mountains. The application starts by playing back historic traffic information in the Denver area. It does this by querying for a time extent. So now that we're querying for the time extent, we're actually moving through the different 1-hour periods throughout the day. So we can see the traffic movement, we can see the traffic patterns, and we can also see incidents. Each incident includes the type, description, start time, expected end time, and when it was last updated. So these incidents are really handy to have as part of the traffic layer. Now that we've reviewed some of the traffic information and some of the incidents, we can see what's going on. What we want to do is plug in some dates to the directions component, which is part of the ArcGIS Maps SDK for JavaScript. What we can do is we can plug the date and time information in for the following day. So we can look at the traffic patterns for that day, and we can start to plan our trip. So the first thing that we do is we plug in the origin and destinations. So the origin is the International Airport. The destinations include Aspen, Powderhorn, Breckenridge, and Telluride. After that, we can calculate the route. So we can see that the total route time is 14 hours and 4 minutes. If we look at the parameters, we can see that the stops have been defined as the ski resort destinations, and the start time is our forecasted time as to when we want to leave. And then the solve operation includes all of those parameters to create this route. Now what we can do is we can use some of the advanced features of the routing service to help optimize our stops. So when we select that particular feature in the directions component, we can see the time is now reduced down to 9 hours and 28 minutes. So that's quite a savings. And if we look at the code window, we can see that the find best sequence value is true, and it's really just one line of code to add that feature and to get that enhancement. Next, we can use the edit tool on the directions component to add barriers to our route, to change the route, to help optimize it, maybe for how we want to travel throughout this trip. So let's say we have information from the locals that describe how this part of the I-70 is really busy, and it's definitely a spot we want to avoid. So we can trace this barrier over top using the directions component, or we can add it programmatically. When we do so, and then we resolve the route, we can see how the route is diverted around our barrier. And now we have a final time of 9 hours, 36 minutes with the total destination driving mileage of 496 miles. So the new route is stop optimized, and even with our custom barriers, it still results in about a 4-hour time cost savings. This example shows how using the routing and traffic services together makes trip planning easier. It also shows how easy it is to develop with the ArcGIS Maps SDKs and the routing service API. Last mile delivery is a specialized routing operation designed for optimizing dense deliveries from a single distribution center. A typical use case is delivering packages, foods, and goods to customers located in a downtown or neighborhood area. This example uses the operation to calculate early morning deliveries for a small fleet of vehicles for a coffee bean company in San Francisco. The application starts by loading a CSV file with 74 orders to deliver. The orders are coming from an online retail system with information such as the name, address, quantity, preferred time window, curb approach, and many, many other parameters can be passed in. There's actually up to 14 different order parameters that can be passed. When it's imported, the data is geocoded and stored securely in ArcGIS. The next step is to input the parameters. The first thing we're going to do is define the number of vehicles, which is 3. The delivery time, or the max time they'll have, is 1 hour, and 7 a.m. as the start time. Before we make the calculation, however, we want to set up the routing restriction and routing rules. So we definitely want to use traffic information. We definitely want to avoid construction. We can also avoid other road types. So for example, we can avoid unpaved roads, carpool roads, express lanes. We can also add vehicle restrictions, such as size, length, height, and hazmat requirements as well. So it's just a ton of parameters that can be passed in here. So once those parameters are set, then we can calculate the delivery problem. So we can see that 30 of the 74 deliveries can be fulfilled with the current parameters that we have. So what we can do is go back to the input parameters, change the number of delivery vehicles to 4, the delivery window time to 2, and now that our delivery window time is wider, now at 2 hours, we need to start earlier. So we're going to start at 5 a.m. Next, we're going to recalculate the delivery problem, and we can see that 74 deliveries were fulfilled. We can also notice that the deliveries are clustered into like their own geographic areas with minimum overlapping segments. The other interesting feature is that only the number of vehicles that are required to solve the delivery problem are assigned to routes. If we have 10 vehicles available, in this case, we're able to solve the routes with just 4. Lastly, we can inspect each route. So we can look at the number of deliveries that were assigned to each one. And we can also look at the different fields, such as the service time, route name, segments, the arrival time of the vehicle, departure time of the vehicle, and so forth. So here we can see there were 16 deliveries total for this particular route. Next one was 22, next 15, and then finally 21 for the last vehicle. So last mile delivery can balance and optimize thousands of deliveries across multiple vehicles. It can also honor all vehicle travel modes and driver time restrictions. The routing API is very powerful, flexible, and easy to integrate with existing online ordering systems. These are just a few examples of the problems you can solve with the routing service. Hopefully this gives you some inspiration and some ideas for types of applications you can build for your organization. Back to you, John.
Thanks, Al. That was more great-looking demos. It's so exciting to see all these great things in action. So the key takeaways for routing are the many unique and specialized routing algorithms, flexible service options, performance, and cost-effective. If you would like to know more about routing services, be sure to check out the Mapping and Location Services Guide on the Esri developer website. So we covered a lot of ground in today's presentation. I hope you found something interesting and you're inspired to try it out. We believe in supporting developers, and we put a lot of effort into making your use of ArcGIS quick, easy, and cost-effective. And we listen to our users, so feel free to reach out and engage with us. There's many ways. I showed you some community options earlier, and you could always reach out to talk to us and engage, and we can help you out. And you can try this all right now. So signing up for ArcGIS is free. Anybody could sign up. All that is required is a unique email address. There's no credit card or any kind of payment up front. You get to pick and choose just the services that you want to use in your applications, and you pay only for what you use and nothing more. And it comes with a generous monthly free tier that you could try out each service. It replenishes every month, and you can even deploy your app against the free tier. And we offer flexible terms of use. Esri is mostly interested in your success, and our terms of use are designed to enable you to build the apps that resonate with your target audience. Deploy as many apps as you want. And all of this is delivered on top of a robust global infrastructure designed to be secure and performant with regional services and CDN caching around the globe. We hope we inspired you to take your apps to the next level with location intelligence. Here are some additional links that you can follow up on and continue your journey and discover more of what you can do. Thank you for attending.